Hello everyone. Sorry, good morning. How is everyone? How are you? Very good morning. I hope everyone is good and you all are preparing well, revising well, not taking much tension, and at the same time doing lots of things. Very good morning, Tripti. Okay, so I had discussed questions from Sunday test yesterday, and there was some question left or something that I missed out on yesterday that I will be discussing a bit. That will hardly take 1 minute or something. So this question I have discussed, right? Here, what we needed to find the angular frequency in SI unit at resonance, right? Okay, my voice is not at all coming. Tripti? Is it not at all audible? Yes. Can I know? Okay, now it's audible. Okay, done. So in this question, what we needed to calculate is we needed to find angular frequency in SI unit at resonance. Done. We have studied resonance when our circuit was LCR circuit and all were connected in series. Done. Here we have studied resonance, and here the meaning of resonance was what? When I was going to be max, and for that what we had done, जैसे यहाँ पे अगर आप I max निकालने की कोशिश करो, then how you will calculate I max? That will be equal to V naught by Z, where Z is the impedance and Z can be written as R plus I cap XC minus XL. And if we have to if we have to maximize current, we need to minimize Z here, right? So minimum value of Z will be when R, we can't make it to 0, then it won't be LCR circuit, but we need to keep both, like all three of these, R, XC and XL. But we can minimize it by equating this to 0. Done. So if XC is equal to XL, then we will get resonance in series LCR circuit, and that value we will be getting as XC equal to 1 by omega C, XL kya hoga? Omega L. So omega we get as 1 by root over LC. Done. That we have dealt with in series LCR circuit. Now, what if the elements are not all in series? How we will calculate like frequency at resonance? First, we need to understand now the resonance meaning changes when we are dealing with parallel circuits, right? In series circuit, resonance means I maximum. Here, resonance means I won't be maximum. Here, I will be minimum. ठीक है? So yesterday, यही वाला mistake हो रहा था. Actually, I didn't pay attention much. So this was a parallel circuit. Now we were solving for parallel circuit. So if you're talking about resonance, we will be going for I minimum here. Done. Again, here we have calculated Z. So Z value here was how much? So यहाँ पे Z क्या होगा? These two in series and this one in parallel. So we need to combine first these two in series. तो यहाँ पे हमने series में इसको combine कर दिया. Now what we need to do? यहाँ पे L like inductor का reactance, what you will be writing? Inductor ka reactance you will be writing as minus I XL. I have discussed yesterday, and here it will be I XC. Done. So we have to combine R and L in series. So combine those two in series first. So these two in series will become how much? R minus I omega L, and these two in series, and this is in parallel with what? That is in parallel with which one? Capacitor. Okay. So we have calculated in the yesterday class 1 by Z equal to what we will be writing? 1 by I XC plus 1 by R minus I omega L. Then we did this, we solved it also. Only thing is we were missing key when we are going for resonance in parallel circuit. Resonance in parallel circuit means we are not going for maximum maximum current, we are going for minimum current. ठीक है, so ये important. Now in this question, here the options are given कि cell was getting discharged and I said कि it is getting charged and that's actually true. So यहाँ पे mistake हुआ है in the question. Done. So that's over. Now this was a question I discussed it while discussing sound wave. Done. So what the question is, there is a wave traveling on a rod of linear mass density lambda equal to ax square, where a is what? Where a is the constant. Now what we need to calculate? First thing that we need to calculate is the velocity of wave at point P. Now at this point P, we have to calculate the velocity of wave. How we calculate the velocity of wave? What's the formula first? तो यहाँ पे फॉर्मूला क्या लिखोगे? वेलोसिटी का फॉर्मूला क्या होता है? रूट ओवर टी बाई म्यू. So if we have to calculate velocity at point P, we should know what is tension at point P, done, and we should know what is mu at point P. So what is mu at point P? Mu is linear mass density, and linear mass density is varying as alpha x square. So for x distance, mu value will be ax square. So that's done. That is sorted. T we need to see कि how much it will be. अब आप यहाँ पे ध्यान से देखो, mu we already know tension निकालना है. So how much tension will be there at point P? So for that we need to see कि what mass is hanging from the point P. What mass is hanging? Whatever mass is there in the length x. Done. And if m mass is hanging, then tension will be equal to mg. Done. So we need to calculate how much mass is hanging. Now how much mass will hang? अगर हमें निकालना है तो let's do one thing. Let's take a strip, very small strip of length dx. How much mass will be there in this small length dx? This mass will be lambda dx. And here lambda is given as what? Ax square dx. Done. So if we have to calculate total mass, this is the dm value. So if we have to calculate total mass, we will integrate. Done. Ax square dx. Done. So integrate from where to where? We have to calculate tension at point P. And point P is at what distance from the bottom? It is at a distance x. So यहाँ पे nothing but 0 to x. So how much value we are going to get? Ax cube by 3. This is the mass. So what will be the tension? Tension will be ax cube by 3 into g. Now what will be the velocity? तो अब आप velocity को लिख दो, बहुत ही easily we can write now. So velocity will be tension, that is ax cube g by 3 velocity by this one ax square, right? Once integration L by 2 से क्या बोल रहे हो? L by 2 से L तक, वो क्यों करेंगे? आप ध्यान से देखो, that we should not do. According to you, you are telling me कि integration should go from x to L minus x. हाँ, that you are telling me ना, क्योंकि point P पे मुझे टेंशन निकालना है. इस मास से हमें कोई मतलब नहीं है. जैसे you just imagine a case, suppose you have taken a very heavy rope is there. Done. And from this rope, this is fixed here, and from this rope a mass is hanging like this. This is a massless rope. Suppose this is a massless rope and this is a heavy mass rope, and from this there is a mass hanging. And what will be tension in the massless rope? What will be the tension in the massless rope? यहाँ पे कोई टेंशन आएगा क्या? बिकॉज ऑफ दिस हेवी रोप. जैसे आप किसी भी चीज को हैंग करते हो, तो अगर इस चीज से मैंने हैंग किया, तो जो मास इससे हैंग है उसकी वजह से ही टेंशन आएगा ना. देन दैट थिंग, दैट वेट विल ओनली स्ट्रेच इट डाउन ना. आर यू गेटिंग मी? व्हाई वी शुड टेक इंटीग्रेशन फ्रॉम L by 2 to L? Okay, done. So b का वैल्यू, how much you are going to get? b का वैल्यू will be x square कट होगा, a कट हो जाएगा, यहाँ पे x बचेगा, xg by 3. Now this is done. Okay, so xg by 3 we are getting. Velocity at point P is this. Then time taken by wave to travel lower half of the rod. So now it is asking ki if lower half को cover करना है, L/2 distance cover करना है from the bottom, how much time it will take? So time taken को आप कैसे निकालोगे? Time taken you can calculate by uh, uh, how you will write distance by whatever distance you are taking, distance by velocity. Done. Clear है? So what will be, just calculate it now. Anyone do it? चलो solve करते हैं, ठीक है? मैं तो कर रही हूँ, but you should now solve it. Time taken by wave to travel the lower half of the rod. Calculate करके बताओ कितना आ रहा है. Yes, I'm waiting for 2 minutes. I want to see you solve the question. From the bottom, we have already got, if we are measuring from the bottom, then velocity at any distance x is this. Then we have to calculate time taken to cover L/2 distance. Let me know what will be the time. ठीक है? Just remember that velocity at different point of the rod will be different. So you just need to first calculate how much time it will take to cover a very small distance dx at some length x from the bottom. How much time will it take? Then you can integrate, right? क्योंकि यहाँ पे velocity is not same throughout. We can't simply write the distance by velocity. क्योंकि velocity profile is changing from bottom to the top. Done. So somewhat integration वाला thing we need to use here also. So आप करके दिखाओ क्या आ रहा. Just let me know the answer. On the way to calculate answers, is it coming? Yeah, any difficulty in understanding, let me know. Because this won't be taking that much of time now. Done. Okay, let's see. So what the question is, there is a rope now, something like this. And what we have to calculate, how much time wave will take to cover L/2 distance. Done. Now let's see how much time will it take to cover any small strip of the string. So let's take a small strip here. So if it is the small strip of length dx, how much time wave will take to cover this strip? So time taken will be equal to how much? Distance by velocity. So if this is a small strip, I have taken a distance x. Then at distance x, at any distance x, what's the velocity is root over xg by 3. So this is the time taken to cover this small strip. We have to calculate time where x is varying from where to where, from 0 to L by 2. Done. So यहाँ पे आप h को vary कर दो 0 से L by 2. You will get the value, right? So you will get the answer. That was the question. Clear है? Everyone done with this question? I hope you all might have got it actually. How much questions on the average you people are solving in exam and physics? How many questions? Okay, 6 to 7. That is good number. Not bad. Okay, done. No issue. चलो ये क्वेश्चन देखते हैं. Again, this question was very easy. Done. We just need to be clear about the basics and a little bit of brain we need to apply. In YDSC setup, at a given instant, what's happening? Only different thing here happening is the separation between this slit initially is capital L, and what is happening? This S1 is moving in this direction. This S2 is moving in this direction. So with what velocity this separation between two slits will increase? Just tell me that in chat section. With what velocity I'm asking, separation between these two slits will increase. Like individual slits are moving away from each other with velocity v meter per second. So my question is, with what velocity separation between these two slits will increase over time? Yes, just think over it and let me know. Yes, so you all might have solved this question now. वही तो सोचना था और कुछ नहीं था. So this is moving with a speed. Separation between these two will change with velocity 2v, है ना? This v velocity will change its separation with v meter per second. This also will change its separation with v meter per second. Overall, relatively निकाल लोगे 2v meter per second आएगा. Done. Now what the question is? अब question पे आ जाओ फिर. Distance between two consecutive maxima. So what used to be distance between two consecutive maxima? That is sorry. That is beta, and beta can be written as lambda d by d. That is that is L here, right? Beta is lambda d by L. Then now distance between two consecutive maxima is changing. Rate of change पूछ रहा है. How we calculate rate of change of anything? Rate of change means with time we have to differentiate it, right? Rate of change of distance, rate of change of velocity, rate of change of acceleration. It means what we have to differentiate them with respect to time, right? So यहाँ पे भी what you do, d beta by dt. Done. Now this L is variable here, no? This L is what? Variable. Lambda d is constant. So यहाँ पे मैं लिख रही हूँ dl minus 1 by dt. Now this L can't be differentiated with respect to time, but we can do one thing. ये तो तुम्हें सबको पता है. We can do something like this. Done. Now differentiation of this thing is very simple. Minus lambda d by क्या हो जाएगा? L square into dl by dt. Rate of change of separation. dl by dt का value क्या होगा? 2v. Done. So what's the correct answer? Correct answer is first one. First one is correct. Now minus lambda d 2v by L square. So first one is correct. Now distance between two consecutive minima. Minima के लिए बीटा का बीटा डैश लिख लेती हूँ टू कंसेक्यूटिव मिनिमा के बीच का भी डिस्टेंस क्या होगा, लैम्डा डी बाई एल ही होगा, है ना, क्योंकि डिस्टेंस बिटवीन टू कंसेक्यूटिव मैक्सिमा और मिनिमा सेम होता है एंड दैट यूज्ड टू बी लैम्डा डी बाई एल, दैट्स कॉल्ड फ्रिंज विड्थ. सो दोनों के लिए ही रेट ऑफ चेंज शुड बी सेम and we have got this as the answer, so this can't be true, right? Distance between two consecutive minima and maxima. What is the distance between minima and maxima? Any consecutive minima and maxima. कैसे निकालोगे? How you will calculate that? एक example ले लो. What will be the distance between first maxima and first minima? If you are going to calculate that. So first maxima के लिए we write d sin theta equal to n lambda. And first है तो n का वैल्यू क्या लेने वाले हैं हम लोग, n का वैल्यू we can take as 1. Now if theta is small, that is usually the case if d is far greater than capital A, so theta equal to lambda by d. Done. So first minima is found at first maxima at what angle, lambda by d. Now let's see first minima at what angle. So d sin theta, first minima we will get for 2n plus 1 lambda by 2, n ka value we will put 0 and that will give us lambda by 2. Now what will be theta? Lambda by 2d. So first maxima at this angle, first minima at this angle. What is the angle difference? Just say first maxima is this angle, first minima is at this angle. This angle is smaller now, this angle is larger. So what's the angle difference between these two fringes? That is equal to theta 1 minus theta 2, that is equal to lambda by 2d. So what will be separation between them? I have told you if approximations are true, this separation can be easily calculated from this angle. You have to simply multiply this angle with capital D. So what will be the distance between a consecutive maxima and minima? That will be equal to lambda d by 2d. So by में 2 आएगा, यहाँ पे जो भी है उसके by में क्या आएगा, 2 आएगा. So same process we will go through. Only difference is half of this will be the answer. So half of this will be what? 2 हट जाएगा simply. So minus lambda dv by L square. Minus lambda dv by L square. So C is correct. Done. So this was the question. Question is damn easy. Now this question, you all know what used to be the formula of RMS thing. Then यहाँ पे क्या निकालना था? There was a molecule of gas has mass of one molecule is given, that is small m, and this is in thermal equilibrium at absolute temperature is given T, absolute temperature in Kelvin it is given. The components of velocity of molecules along the x, y and z axis are given. Average value of this we needed to calculate. So this question was very easy. Again, Vx plus Vy plus Vz का स्क्वायर, ये किसके बराबर होगा? Vx स्क्वायर प्लस Vy स्क्वायर प्लस 2 Vz स्क्वायर प्लस 2 Vx Vy plus Vy Vz plus Vz Vx, something like that. Done. We need to calculate the average of this one. So if I take average on the LHS, we will take average on the RHS. Done. Now you must remember the way, if you remember the way you have calculated VRMS, you must be clear about it. We have seen in that derivation or I can just say here if gases molecules are there in the container, if there is gases molecules in container at any temperature T, they will be randomly moving. Done. So if their velocity is in x direction at certain instant of time having some value, then on the average, how many, if some particles are moving in this direction in T time, then equal amount of molecule we can say will be traveling in this direction also. Done. So on the average, if you are going to see average velocity of gaseous molecule in the x direction, y direction, z direction will come as 0. Why? क्योंकि हमारा molecule जो है वो किसमें है? Random motion में. And if anything is in random motion, its velocity in any particular direction can be taken as 0 when we take its average. Done. So similarly, we can say Vy average क्या हो जाएगा? 0. Vz average क्या हो जाएगा? 0. And this thing we have done while doing the calculations, है ना? While doing the derivation. तो सेम थिंग आई विल बी अप्लाइंग हियर। तो यहाँ पे अगर आप एवरेज ले रहे हो आरएचएस साइड में भी, तो एवरेज ऑफ दिस टर्म, एवरेज ऑफ दिस टर्म प्लस एवरेज ऑफ दिस टर्म, सो इस टर्म के अंदर चले जाओ तो 2 into Vx एवरेज Vy एवरेज प्लस Vy एवरेज Vz एवरेज, सो इसका वैल्यू टोटल कितना आने वाला है, 0 आने वाला। डन, एक टर्म बच गया हमारा एंड दैट टर्म इज वो, क्योंकि Vx स्क्वायर का एवरेज 0 नहीं होगा। डन, Vx का एवरेज क्या होगा, 0 होगा। तो अब आप यहाँ पे देख लो, Vx प्लस Vy प्लस Vz का स्क्वायर इज इक्वल टू हाउ मच, Vx का स्क्वायर प्लस Vy का स्क्वायर प्लस Vz का स्क्वायर का एवरेज, इसके बराबर है। डन, एंड दिस टर्म, इस टर्म को केयरफुली देखो तुम लोग। आरएमएस हम लोग कैसे निकालते थे, इफ यू रिमेम्बर, आरएमएस तुम लोग रीड कैसे करते हैं, इस साइड से रीड करते, फर्स्ट वी डू द स्क्वायर, देन वी टेक द मीन दैट इज एवरेज, देन वी टेक द रूट। So if we have velocity of a molecule in 3 direction as Vx, Vy, Vz, and if we have to calculate their RMS, first we will do the square of each velocities. So हमने इसका square कर दिया, उसके बाद क्या लेंगे, इसका average. So average how we will take, we will add them and take their average. Then we will add them and divide by 3. अगर एक molecule है और उसकी ऐसी ऐसी velocities है तो done. So average we take, clear है, and then we take the root. Then this will be the case if we are taking single molecule, but in the container single molecule तो नहीं होगा, उसके पास बहुत सारे molecules होंगे। Then so overall what we do is कि we calculate हर molecule का Vx स्क्वायर प्लस Vy स्क्वायर प्लस Vz स्क्वायर, और उसका क्या लेते हैं हम लोग, एवरेज लेते हैं। सबसे पहले स्क्वायर करते हैं, फिर मीन करते हैं, और उसके बाद क्या करते हैं, रूट करते हैं। तो ये किसके बराबर है, अगर इसको मैं रूट कर दूं तो ये किसके बराबर है, दिस इज इक्वल टू वी आर एम एस। नाउ वी आर एम एस इज इक्वल टू हाउ मच, इट इज इक्वल टू 3RT बाई एम रूट ओवर। डन, so VRMS is equal to this. If we are going to square it, what we will be getting, यहाँ भी square मिलेगा, that square term is there on the RHS side. So यहाँ पे होगा 3RT by M. This M is what, molar mass. This is universal gas constant. Now here in the question, M is not given, small m is given, that is mass of one molecule is given, right? So how we can do that now, 3RT, M can be written as Avogadro number into mass of one molecule, क्योंकि molar mass means mass of one mole. One mole means how many molecule, any number of molecule. Each molecule is how much mass, small m. So this can be written as this. Now R by Na is equal to K, that you already know. So this is 3kT by m. So the answer here, this will be equal to 3kT by m. So that you will get as the answer. So यहाँ पे basic thing was कि if you know the derivation वाला part or not. चलो done. So this was the question we left at while we were discussing thermal physics. So again, I want you to go through this thing. Actually, that day I gave some 2 minutes to this question also. So you all must have gone through it completely. So again, I'm giving you 2.5 minutes. Tell me the answers and do it very wisely. Okay? Question is not at all difficult. It's very easy, but be careful. क्योंकि if you're not careful, you will mess it up in the sense कि calculation आप lengthy कर सकते. Just look at things and let me know the answer. in 2.5 minutes, at least you should come with one answer. Okay, just check the first one at least. Whatever you are getting, keep communicating. Okay, let me know through chat box also. First one, any one of you check option one. No. Work done in this thermodynamic cycle 1 to 2, 2 to 3, 4 to 1 we have to calculate. So work done from 1 to 2 will be how much? 1 to 2. 1 to 2 is this. So first try to see that this process is what? I mean, is this isochoric, isobaric, isothermal, whatever. So here you see this is a VT curve. So to check from graph which process it is, just write the equation, ideal gas equation, PV equal to nRT. Done. And this equation is between, this graph is between voltage. No, this is between volume and temperature. So volume by temperature here is equal to how much? nR by P. And here you can see volume by temperature, that is the slope. So here graph is a straight line. So straight line will have a constant slope. So this value is going to be a constant. So pressure is going to be what? Because N is constant, that is 1 mole. R is a constant, so pressure must be constant. So this is a constant pressure, 1 to 2. Now work done in isobaric process is what? P delta V. Done. So calculate pressure at any point. 1 पे जो pressure होगा वही 2 पे होगा. So calculate pressure at any one point. So if you are going to calculate the pressure from here, we can do that. Suppose at point 1 I'm taking, at point 1 temperature is how much? T naught. Volume is how much? V naught, mole 1 into R by P. So P value is how much? T naught by V. So P is T naught by V. V naught. Let me write it like this. Now what will be the delta V? As we are going from 1 to 2, volume is changing at what? From V naught, it is changing to 2 V naught. So there is a case of expansion actually. So work done will be positive and something like this. So work done is how much? It is, sorry, pressure क्या होगा? R का term भी होगा ना? T naught R. Done. So how much value we are going to get? We are going to get R T naught. Work done from 1 to 2. Now work done from 2 to 3. 2 to 3 में आप clearly देख सकते हो volume is remaining constant. So that's the isochoric process. Work done will be 0. Now work done from 3 to 4. 3 to 4 again it's a straight line. So this is an isobaric process and work done will be written as P delta V. So let's calculate pressure at point 3 or at point 4, wherever you feel comfortable in. So चलो 4 पे ही मैं निकाल लेती हूँ. What will be pressure here? So here volume is V naught, temperature is T naught by 2. So it will be something like V naught by T naught by 2 equal to R by P. So what will be the value of pressure here? Pressure will be T naught by 2 R by V naught into, now pressure into volume change. So if you're coming from 3 to 4, it is a case of compression, 2 V naught se V naught. So final volume is V naught, initial volume is 2 V naught. So what answer we are going to get? T naught R by 2 with negative sign. So these are the work done 1 to 2. This is 2 to 3. This is 3 to 4. And what will be work done from 4 to 1? That will be again 0 because volume is not changing. What will be the total work done? Now you can write total work done. No? You can simply add these 4 terms. So R T naught minus T naught R by 2. So R T naught by 2. First option seems correct. Now ratio of heat transfer during process 1 to 2. Process 1 to 2 is what? Isobaric. And in isobaric process, we can write heat very easily. Q in isobaric process, that is QP, will be equal to NCP delta T. I have discussed this thing, how we write heat in different processes. If constant volume, QV will be equal to NCP delta T. If constant pressure, QP will be NCP delta T. And if it is polytropic process, for that I have given the value of C. So heat will be NC delta, right? Now, ratio of heat transfer during process 1 to 2. So 1 to 2 is a isobaric process. So 1 to 2 heat given will be NCP delta T, and 2 to 3. 2 to 3 is what kind of process? Isochoric process. So heat given at constant volume hoga 2 to 3 done, and that will be equal to how much? NCP delta T done. Now 1 to 2 or 2 to 3 के heat given का ratio लेना है. So NN, same number of mole is there. Delta T got cancelled. So Cp by Cv will be equal to how much? This is a monoatomic gas. So this will be equal to 5 by 2R and this will be equal to 3 by 2R. So the correct answer will be 5 by 3. Again, this is correct. Then the above thermodynamic cycle exhibit only isobaric and adiabatic process. No, यहाँ पे isochoric process है, adiabatic है नहीं. The ratio of heat transfer during process 1 to 2 or 3 to 4. You can check this now. है ना? So check this and let me know if this is correct or not. Option D. Let me know if this is true or false. Take 1 minute and let me know. This question came very recently, just 1-2 years back. Chalo, let me know the status of question option D. Ratio of heat transfer during process 1 to 2 and 3 to 4. Which one is 3? This is 1, this is 2, this is 3, this is 4. Yes, one's correct. 1 to 2 और 2 to 3 में मैंने डेल्टा टी कैंसिल किया क्योंकि टेम्परेचर डिफरेंस वाज सेम. 1 to 2 टी नॉट से 2 टी नॉट, 2 to 3 2 टी नॉट से टी नॉट. सो मॉड्यूलस ऑफ डेल्टा टी वाज सेम और यहाँ पे हमें मॉड्यूलस निकालना. ठीक है. सो ऑप्शन डी विल बी रॉन्ग एक्चुअली. मोस्ट ऑफ यू मस्ट हैव गॉट इट. क्योंकि यहाँ पे हीट गिवन फ्रॉम 1 to 2 को आप क्या लिखोगे? 1 to 2 इज एन isobaric process, so you will be writing NCP. Delta T value will be 2 T naught minus T naught. Now 3 to 4, this is also an isobaric process. So here you will be writing NCP. Delta T will be how much? At 3 temperature is T naught, at 4 temperature is T naught by 2. So this is modulus अगर मैं लिखूं तो T naught minus T naught by 2. So this is T naught by 2 and this is T naught. So this by this will be equal to 2, not 1 by 2. So this is wrong. Now let me know this, please, fast. You don't need to solve, you just need to observe things carefully. So I'm going to give you some 3 minutes, but in that 3 minutes you will be communicating and letting me know which one is right and which one is wrong. This question also came, I think, in 2021 or 20 or 23. Because these are some of all last 3 years question. Okay. Okay. Once I'm doing one thing, I'm just sharing my ID with you. You can text me there. Huh? Okay. Just send me the question. Done. Send me the question. I will clarify that. No issue. So first is correct or wrong? First will be true or false. Process 1 is isochoric. Just look at the diagram, you will get the answer.
Wrong.
Yes. What about others? Yes. What about second? In process 2, gas absorbs heat. How you will be checking that process 2? How you can check that heat is getting released or absorbed? Again, use first law of thermodynamics. Q equal to W plus delta U. Just see in that process, in process 2, W sign is what? Delta U is sign is what? I mean, sign means positive or negative. Q is getting absorbed means Q value will be positive. If Q is getting released means sign convention of Q will be negative. That we already know now. So in second process, what will happen? Okay, I will look at this question. No worries. Okay, Tripti. I have gone through that question actually. I couldn't include, but I will let you know. Huh? But for now, let's discuss this. Okay, Tripti, yes. Okay, good. Let me know about option C. And others, please, option B will be what? True or false?
Two.
Okay, done. Because here temperature is not changing, so delta U is 0. Now, what about W? Here volume is increasing, so work is being done by the system, so that is positive. Q is positive. It means heat is getting absorbed. Now, what about the process 4? 4 is just opposite of second now. Again, here also temperature is constant. You just see carefully. Let me know. Yes, once. Yes, let me know first. C option is what? True. Okay. And what about the option B? C will be also true now. Because in the process 4 gas is actually getting released because here volume is decreasing, work done is negative. So work done is negative, delta U is 0, temperature is not changing. So Q is negative, it means heat is getting released. What about the process? Yes, D also false because process 1 and 2 are not isobaric. This is isothermal, and here this is not isobaric क्योंकि यहाँ पे T by V curve is not a straight line. Then this is somewhat curved. So again, that's not true. So D option is also what? True. And C option is also true. B is also true. D was false, no? Done. A was false, sorry. Chalo. Now do this question. I am giving you some 5 minutes for this question. Read the question carefully. ठीक है? आप आराम से time लो. Try to understand the question and then do it. TV graph में, if you have to check for the adiabatic, then TV gamma minus 1 will be what? Constant. ठीक है? So T is V gamma minus 1. Done. And this graph will look like what? It won't be a straight line. Done. It will be somewhat curved. क्लियर है, लेकिन यहाँ पे हमारे पास कोई डाउट नहीं था इस ऑप्शन में. क्यों? क्योंकि प्रोसेस 1 एंड 2 आर नॉट आइसोबारिक, दोनों को ही आइसोबारिक के टर्म में ले गया. सो यहाँ पे कोई कंफ्यूजन नहीं हुआ. डन. लेकिन एडियाबेटिक होता लाइक पहचान पाना यहाँ पे दिस कर्व कैन बी एडियाबेटिक क्योंकि यहाँ पे टी इनवर्सली प्रोपोर्शनल क्या होगा? V गामा माइनस 1. वाई इज एक्स वाई का ग्राफ कैसे बनाते हो? हाउ यू ड्रॉ द ग्राफ ऑफ एक्स वाई? अच्छा, जनरल पूछ रहे हैं. ओके, सो जनरल तो यही है ना, ये क्वेश्चन से जाओगे एंड रेस्ट इज योर मैथमेटिक्स. सो इट विल बी कर्व्ड समथिंग लाइक दिस. इफ A to B is something expansion होगा तो ऐसा होगा, compression होगा तो you will go from here to here. So it will be curved. Done. Now take time to do this question. Understand it first very well. And सबसे पहले तो option 1 का मुझे आंसर बताना, या फिर whatever options you're getting, just let me know. In case of any doubt, you can ask me. Or if somewhere you are getting stuck, then also you can ask me. Also, if you have trouble in understanding the question, then also you can ask me, but first you should go through it and try to understand. Done. How many of you got the question clearly? I mean, how many of you understood the thing clearly? Okay. Done. So let's see one thing. Suppose there is a container of gas and there is a piston kept here. Done. Now what's happening? Yahan pe some n number of moles of molecules are there. Now what will happen if you are supplying it heat? Slowly, slowly, slowly. What will happen? Two things might happen depending on how we are supplying heat, right? If we are supplying heat slowly, then what will happen? And if we supply heat very fast manner, what will happen? In both cases, one thing is common, expansion to hoga. Done. Because if we are giving heat, atoms will or molecule will gain more energy. Temperature will increase now, so their internal energy will increase, and they will start hitting this surface with more force. Done. Because their randomness will increase. If it is hitting this surface with more force, what will happen? It will go up. Done. So it will start moving. Now, if we give it large amount of heat all of a sudden, and if we suppose 200 joule of heat we are giving to this container, in first case we gave it very slowly. Done. So if we are giving it very slowly, change in internal energy in a very small fraction of time will be very small. Done. And that is why this force acting on this surface will not change by very large factor. It means what? It means whatever pressure initially when we were not giving it heat, then what was the case? It is at rest. It is at rest now, this surface. So atmospheric pressure is acting on it. Done. And from inside also some pressure must be acting because of these things. because of the gas contained. So these two pressures must be equal. That is why this is at rest. Done. Now what's happening? We are supplying it heat. This pressure P will increase. Done. But if we are giving this very slowly, what will happen? This change will be very much insignificant. And during that insignificant time, it will move a very small distance upward. And it will move in such a way that it will balance the pressure outside and inside. यानी कि isobaric process हो जाएगा. Pressure will remain the same. Done. But if you are giving it heat in a very large amount of heat in a very small amount of time, इसके पास इतने adjustment करने का समय नहीं रहेगा. All of a sudden its pressure will increase to large value. Done. And then the way it will go up, that process, the process through which it will go up, this surface will go up, won't be isobaric. Done. So that's also called irreversible process. You must have studied that thing. So ये मैंने क्यों explain किया? क्योंकि यहाँ पे you just see the gas is then heated very slowly. Gas is getting heated here very slowly. Again, does that mean pressure inside will remain the same? We need to look at the question again. क्योंकि this question is not this simple. Here what is happening, instead of piston, it is connected with a spring, and that is connected to another container having air. Then so यहाँ पे atmospheric pressure रहा होगा. Clear? So this is something like this. Now let's read the question. There is an ideal monoatomic gas confined in a horizontal cylinder by a spring-loaded piston. Done. Initially, gas is at temperature T1, P1, and volume V1. Initial parameters are given. Initial parameters are P1, V1, and T. Now what is happening? Gas is then heated very slowly to temperature T2, P2, and V2. So what's the final parameter? P2, V2, T2. Done. During this process, piston moves out by distance x. Now here, why these two pressures? Like why here pressure will not remain same as the atmospheric pressure? Why? That's the question. क्यों? क्योंकि यहाँ पे एक spring का factor है. What will happen here? As we will give it heat, a pressure will start acting here, and that pressure will compress the spring. So as a spring will get compressed, this compressed spring will apply force on this thing. Done. So on this surface, in the forward direction, force getting applied is because of the pressure of this gas, and that is how much. अगर मैं इसका FBD लिखूं, जो movable layer है, movable layer का मैं FBD लिखने जा रही हूँ. So how we can write its FBD? Here the force acting will be how much? Some pressure, suppose कर लो P है, A है. And here what will be the pressure acting? That is atmospheric pressure. It is maintained at that. It will remain same because here heat is being supplied very slowly. So this is not going to change drastically during this process. Done. But this has to change. Why? क्योंकि आप यहाँ पे देख लो. Here spring force will act. So PATM can't be equal to P here. It can't be equal to this, right? So it will be equal to what now? So inside pressure, that is how much it is finally P2. So P2A must be equal to initial pressure inside was how much? P1. So P1 must be equal to P atmospheric. So P atmospheric को मैं P1 लिख रही हूँ. P1A क्योंकि initially this is in rest ना, when we were not giving it any heat, and initially spring is not compressed or extended. So spring force is 0. So pressure on the both side must be equal for this to be in rest initially. Done. That is why I have written P atmospheric as P1. So P1A plus Kx. Now P2A minus P1A will be equal to how much? Kx. Done. What we have to calculate? We have to calculate energy stored in the spring when V2 ka value is given in terms of V1, T2 value is given in terms of T1. Done. How we will calculate energy stored in a spring? So energy stored in a spring का formula क्या होता है? अगर मैं A option की बात करूं तो energy stored in a spring will be half Kx into x. Why I'm writing like this? क्योंकि Kx value we have already got. That is P2M minus P1A. Now, how we will calculate the value of x? So, let's go on to the next page. So, what's happening here? This was the container and this was the movable layer. Done. and this was connected to spring, something like this. So as the heat is getting supplied, suppose heat started getting supplied at T equal to 0, and at T equal to T, that heat supplied stopped. So during that process, what must have happened? This movable layer must have come somewhere here, and the spring must have got compressed. Done. So volume is changing by what fraction? By what amount actually here? So if its area is A and this length is A, should be X. If a spring is getting compressed by X, this distance must be X, right? So change in volume here is how much? AX. And change in volume is equal to how much? V2 minus V1. So X का value मुझे कितना मिल जाएगा? V2 minus V1 by A. Just to make the calculation easy, I didn't calculate the value of K. Kx I got here ना, तो मैंने उसको वैसे ही छोड़ दिया, क्योंकि X we can easily calculate from volume change, and volume change is given in the question ना, so then it will be easier to calculate. तो चलो अब calculate कर लेते हैं energy. So what will be the value of energy now? Half Kx. Kx का value is how much? It is P2 minus P1 into A. So P2 minus P1 into A, and X is how much? V2 minus V1 by A. So A got cancelled. What the answer is? Half P2 minus P1 into V2 minus V1. Okay. Now you can calculate the value of P2. Because V2 is given, P2 is given, we can easily calculate here P2. How? Just use the equation that universal gas wala equation, ideal gas equation I'm talking about. So if you are going to use that equation, what you will get? PV equal to what? nRT. Then N value is not given in the question. N value is not given, but initially it is given that pressure is P1, volume is V1, temperature is T1. So N value can be written as what? P1 V1 by RT1. Then so N value we have got. Now let's calculate the V value. So V at any point can be written as nRT by P. ठीक है? So यहाँ पे आप बस pressure को लिखो. Pressure is nRT by V. Done. And N value we have written as P1 V1 by RT1 into R. Pressure P2 लिखना है, तो यहाँ पे T2 लिखना होगा, यहाँ V2 लिखना होगा. Done. So T2 value in terms of T1 is given now, that is 3T1. So यहाँ पे आप 3T1 लिख डालो, and also V2 value is given in terms of V1. That is how much? 2V1. तो यहाँ पे आप लिख डालो 2V1. अब जो भी है उसको कट करो. So how much value we are getting here? P2 का value कितना दिख रहा है? That is your 3P1 by 2. ठीक है? So this is 3P1 by 2. 3P1 by 2 minus 1. You will do, then you will get how much? P1 by 2. And this is V2 minus V1, 2 V2 minus V1, so that is V1. So how much value we are going to get? 1 by 4 P1 V1. So this is true. Done? Clear है? So this way we will be doing the calculation. Clear है? Anyone, any doubt in this calculation or in understanding anything? If any, let me know. क्योंकि if we have understood the first, we can proceed ahead with option B, C, D. So अब आप करो. Do the option B, check option B, check option C, check option D. Change in internal energy you have to calculate now. So change in internal energy calculation is very easy. No matter what the process is, just close your eyes and write change in internal energy always in any kind of process as NCV delta T. Since this is a monoatomic gas, CV का value क्या होगा? 3 by 2R. N value we can calculate. Delta T is given for the process. So chalo, let me know the answer of B. Is B correct or wrong? Rishabh, what happens? U जो है ना internal energy, that is a state function. So it doesn't matter what is happening in between. Doesn't matter. Just like you calculate displacement now. Displacement कैसे निकालते हो? Initial point from the point at which person started और जहां पहुंचा, उन दोनों पॉइंट्स को सिंपली कनेक्ट करते हैं. वी डोंट केयर अबाउट कि वो बीच में कैसे गिरा, है ना. सो सेम यहाँ पे वी डोंट नीड टू केयर अबाउट कि वो कैसे कैसे हो रहा है. सिंपल है, आंख बंद करना है, डेल्टा यू को हमेशा ही एनसीवी डेल्टा टी लिखना है, वट एवर बी द प्रोसेस. Who is right or wrong? Let me know. What happened? You just need to put the formula. Change in internal energy in CV delta T. N का वैल्यू क्या होगा? T1 given by R T1. CV 3 by 2R. Delta T is what? T2 is given now 3T1. So delta T will be what? Initial temperature T1, final temperature 3T1. Just write the value and let me know. क्या कर रहे हो तुम लोग?
V is correct.
हाँ क्या?
V correct है.
करेक्ट है. यस. डेल्टा यू क्या होगा तुम्हारा? एनसीवी डेल्टा टी. एन का वैल्यू क्या है? T1 given by R T1. CV क्या है? 3 by 2R. डेल्टा टी क्या है तुम्हारा? 3T1 minus T1. देखो, every time it's not important to figure out the process. ठीक है, क्योंकि every time we can't. Polytropic process भी हो सकता है ना. Process may be anything, like sometimes it's not defined, so it's a polytropic process. Again, we don't have to go there. If we can solve from whatever information is given, we should not bother about that. Done. So यहाँ पे process को पता करने की जरूरत ही नहीं है. Internal energy, whatever be the process, वो तो हमने लिख लिया. हो सकता है your concern may be कि how we will calculate the work done. Done. So if you don't know the process, we don't know, and nothing is given. Polytropic है, but process बताया नहीं है x का पावर क्या होगा. जैसे polytropic process we define as PVx equal to constant. Now x value is not given. Nothing is getting talked about the process. So we must apply some other ways here. We must adopt some other ways to get the answer. And what will be that some other way? अब आप यहाँ पे देखो, मुझे work done निकालना है. Work done by the gas. So if this gas is doing some kind of work, यहाँ पे क्या है? This is a movable layer. Then we are supplying it heat Q, and this Q heat, अगर first law of thermodynamics लिखो, तो Q will be equal to W plus delta U. Done. Now this Q will get divided into W and delta U. What will be the work done by this gas? What will be the work done? You just see here, this layer will move, and if this layer is moving, what is happening? This is expanding. Done. And at the same time, some amount of its work is getting stored in the form of potential energy also. So this work done is getting divided into two parts. Then one will be half kx square, and another will be whatever work it has done in expansion. Done. And similarly, इसको अलग तरीके से भी देख सकते हैं. This compartment is expanding, at the same time this compartment is what? This compartment is getting compressed, and I have said कि यहाँ पे pressure constant है, that is equal to P ATM. That will remain same as P1. So instead of calculating how much work this gas is doing in getting expanded, we can calculate how much work it is doing in compressing the another compartment. है ना? So that also we can do. How much it is getting compressed, how much it is getting compressed, volume कितना compress हो रहा है. Done. So the same value जिससे first compartment expand हो रहा है, by same value of volume second compartment is getting compressed. Done. So if its volume is changing from V1 to V2 and volume changes delta V, same volume change is happening for the second compartment, right? Delta V. So यहाँ पे work done will be P1 delta V. Done. Again this work done half kx square. और अगर carefully देखो तो P1 delta V को क्या लिखेंगे? P1 AX. P1 AX we can write now here. Delta V is what? AX, and we have calculated the ways to, we have seen how we can calculate AX. AX is this much now. Done. And also KX we can calculate from here. Done. But here see the variables are different. V2 here is 2V1 and here it is 3V1. Here T2 is 3T1 and here it is 4T1. So energy stored in a spring in first case value was this one. That value won't be same in the C case. क्योंकि यहाँ पे क्या है हमारा final parameters are differently given, right? So we need to calculate. But how to calculate that we already know. So यहाँ पे heat given we can calculate easily. Done. Heat given we can calculate. Delta U we have already calculated in the second option. W we can calculate from here, right? So that we can check with. Now what will be the other thing is what? Work done by the gas that we can calculate. Heat supply to the gas, so that also we can calculate. So C and D option is, C option is all about this and D option is all about this. So you just need to put the value and get the answer. So I hope you will be doing this. Chalo, because we need to move ahead also. Let me discuss something that is heat flow. You must all have studied it. The rate of heat flow is written as thermal conductivity of material, area of cross section, delta T L. Again, important thing is जैसे हम जब पढ़ रहे थे current and while we were using Ohm's law, what the important thing was the resistance were written as rho L by A. Again, important thing is L will be taken as what, A will be taken as what. Meaning अगर मेरे पास suppose कर लो कुछ ऐसा conductor है, done. So if this is maintained at voltage V1, this is maintained as voltage V2. So potential difference is along which line? Along this line. It means current will flow. If V1 is greater than V2, then current will flow in this direction. So here length will be taken as this one and area will be taken as this one. Lekin, suppose what I am doing, I am taking the same conductor and now what I am doing, I am maintaining its voltage as V1 and this voltage as V2. Now what will happen? Again, V1 is greater than V2, current will flow in this direction. Done. So now area of cross section will become what? Curved area. Sorry. Done. And what will be the length here? Equal to the diameter. Done. So while you will be dealing with slabs or while you will be dealing with heat flow through slabs, you will have to be very careful about which we will consider as A and which we will consider as L. How you will understand that? Just see the temperature difference is maintained between which 2 points. If it is between these two, then this will be taken as length and this will be taken as area. Area is always the door in which heat or current is entering. So यहाँ पे enter कर रहा है इसपे, this will be taken as area. Here it is entering here, so this will be taken as area, right? This is this. Now what else? We can compare this with current, है ना? यहाँ पे we can write heat current as temperature difference maintained between two ends of the slab divided by L by K. Current को हम लोग क्या लिखते हैं? Current is written as V by R, delta V by R. R is written as what? Rho L by A. So there is quite a good analogy between these two. Delta T, delta V, L, L, A, and rho is what? Resistivity. So 1 by K is what? Resistivity. है ना? यहाँ पे 1 by rho अगर मैं लिखूं तो sigma हो जाएगा. That is conductivity. And here K is also what? Thermal conductivity. So what I want to say is ki here in the case of heat flow through slabs, you can also check if slabs are in series or parallel. जैसे ऐसा कुछ slab है, if one slab is kept over another and here temperature is maintained suppose at T1 and here it is maintained at T2. So these two slabs are in what? Series or parallel? जल्दी से बताओ, these two slabs are in series or parallel? You all must have studied now this one. Yes, Tripti. Others, please.
Parallel.
Yes. This is in parallel, right? क्योंकि temperature difference. Okay, done. सभी जानते हो तो explain करने की जरूरत नहीं है. Done. So this is in parallel. If we have to calculate heat flow value between these two, how we will be writing heat flow? dH by dt we will be writing as T2 minus T1 by R equivalent. Done. R1 का वैल्यू हम लोग क्या लिखने वाले हैं? L by K1A. If its thermal conductivity is K1 and its it is K2. Length is same, so R2 value will be written as what? L by K2A. Now, since these two are in parallel, यहाँ पे R equivalent जैसे निकालते हो registers के केस में in the same way you will be doing. ठीक है? Don't remember any other formula I will say, क्योंकि all other formula for this thermal conductivity वाला thing is for certain cases. I mean, जब तुम्हारा length और area equal है, then some formulas are correct. So there are different cases in which formulas are true. So don't remember any formula. Only remember this formula. Done. And how this one means how we can simply change this to the form of delta T by R. बस ये formula याद रखना है और कुछ भी आपको याद रखने की जरूरत बिल्कुल भी नहीं. Done. This you should not. Now let's do this question. This question is damn easy. I'm just giving you only 2.5 minutes, and this also I gave because you will take time to read the question. That is why I'm giving this much. Otherwise, I would have given only 1 minute. चलो जल्दी से करके बताओ what will be the answer. Everyone, I'm expecting answer from everyone. Please do it. हो रहा है सबका? In the process or what? Is it happening? Each slab is of equal dimension, right? Area and length for each one is same. Thermal conductivities are given in your question, right? Yes, correct. Very good. Others, please. Yes, Rishabh. Tripti, done. Very good. Others, please. Chalo, let me know what will be the answer once. In configuration 1, these two are in what? Series or parallel? Temperature difference is maintained along the x-axis. It is given in the question. Temperature difference between A ends along the x-axis in both the configuration. Done. So temperature difference is maintained along x-axis means if it is T1 here, it must be T2 here. Done. And it takes 9 seconds to transport a certain amount of heat from hot end to the cold end in configuration 1. The time to transport the same amount of heat in configuration 2. So amount of heat getting transported is same in both the cases, but we have to tell key in first case it is taking 9 seconds. So in second case, how much time will it take? Now dH by dt will be written as what? Delta T divided by what? Delta T by R equivalent. So just calculate R equivalent in each case. Here it is in series now. So individually first let's see what the resistance of thermal resistance of first slab. So this will become of K, it will be R1, how much? K1 L by A. Okay? And K1 is K, nothing but K. So if for this slab I write resistance, it will be how much? 2K L by A. So chalo, I'm going to make it look more easier. L by K L by A को मैं R0 बुलाती हूँ. So R1 is R0 and R2 will be 2R0. Similarly here, this has individual resistance of how much? It has individual resistance of 2R0 and it has individual resistance of R0. Take it. So this is going to happen. Now these two are in series. So series में this will become 3R0. So dH by dt in first case is how much? Now I am going to write for the both configuration. So for configuration 1, dH dt is how much? 9 seconds. Temperature difference maintained is same. So delta T by how much this is? R equivalent in first case will be how much? 3R0. Now in second configuration, if you are going to write dH by T time, we don't know time, delta T by what will be the value of these two resistors? These two are in parallel now. So you will be writing R0 into 2R0 by 3R0. So how much value it will give? 2 by 3R0. Done. Now divide these two. DH will get cancelled. Delta T will get cancelled. T by 9 will be equal to how much? 3 by 2 into 3. So और गलत लिखा मैंने. एक सेकेंड, कैलकुलेशन सही से करो. This is 2 by 3 now. So this will go 2 by 3. So this is upside now. एक second. So this can be written as how much? 1 by 3 R0 delta T. and this is equal to how much? Delta 3 delta T by 2R. If you're going to divide these two, 3 will get multiplied now, and that 2 will go up. So 2 by 9. Done. How much value of time we are going to get? 2 seconds. Okay, done. So the answer will be 2 seconds. Now in radiation, questions are very easy from this portion also. Again, just let me take you through the formulas. So if you have a body, then it has temperature T, how much power it will generate? Because any body that is having a temperature T, it will radiate some energy, and that energy radiated per unit time is what? Sigma EA T to the power 4. Sigma is Stephen's constant. E is emissivity. A is what? Area of the surface. Yani ki this surface, if it is a sphere, it is 4 pi r square. And the temperature is always written in Kelvin. This thing you have to keep in your head, to the power 4. So if a body is kept in an environment of temperature T naught, then some energy it will radiate and some energy it will also absorb from the atmosphere. Because if atmosphere had temperature T naught, that atmosphere will also radiate energy. Then, so that energy radiated by atmosphere will also fall upon this body. Then, so net energy emitted by this body will be how much? It is absolutely, it is emitting how much energy? Sigma EA T to the power 4. How much energy it is absorbing? Sigma EA T naught ka power 4. So net energy, this is getting emitted and this is getting absorbed. So net energy getting emitted is this minus this. So this is this. Okay, for black body, E is 1. Black body is a perfect absorber. You already know. Wind's displacement law talk about if there is a body at temperature T, it will radiate energy, and this energy radiated will belong to various wavelengths. So if energy it is radiating, it will have many wavelengths. E is emissivity. E is emissivity. For black body, it is 1, and for any other body that will be given in your question. Okay? Now, this energy getting radiated will belong to a spectra of energy, means there will be various wavelengths, infinite wavelength can be there. But the thing is ki at which wavelength, yes, Naman, at which wavelength it will generate maximum energy. So this is the graph. This is intensity of light getting generated or getting emitted, and this is the wavelength. So at certain wavelengths, it is emitting maximum energy, and that is called lambda m. Lambda m value we can calculate. इससे question भी आया है 2018 में ही आया है, I guess. So lambda m can be written as lambda m into T can be written as B. B is a constant. Again, that will be given in your question. That is around 2 point something. Again, this is lambda maximum. This is the wavelength at which maximum energy is getting generated. This is temperature of the body. Again in Kelvin. Here from the graph, you can say, you can see that this body has maximum intensity at lower wavelength, and this body has maximum intensity at higher wavelength. So from this graph, we can say T1 is greater than T2. How we can say that? जैसे आप कहीं भी जाओ, एक जैसे किसी भी चीज को जलाते हो, तो सबसे पहले the light that it comes from it, जैसे लोहा ले लो, if there is an iron, and what is happening, you are giving it heat. So initially its color will look like yellow, but as you will give it more heat, its color will turn yellowish. Sorry, bluish. Why bluish? Because at very high temperature, it is generating energy that is falling mostly in the blue color region. Then that is why it's looking blue. Iska matlab, if temperature increases, intensity of maximum energy getting generated will have wavelength what? Will have lower wavelength. So these things you must have already studied actually. I just wanted to go through it again. I will suggest here, तुम लोग क्या करो, tension बिल्कुल मत लो, cool and calm रहो, go through revision, revise a lot, ठीक है, without taking any further tension, and don't do questions from अजीब से books. Just do previous year questions for now, and अभी के लिए तुम्हारे पास दो ही चीज होने चाहिए, previous year questions and test questions. इसके अलावा don't go anywhere, only do revision. open your textbook. If you need to revise the formula, again, revision should not be like if you have to read the, suppose you have to revise the thermodynamics chapter. It doesn't mean you will go through the theories, formulas, and trying to remember it. No. What you should do, ideally, you should open questions. And which question? Which questions? PYQs and test questions. And do solve those questions of thermodynamics if you are revising thermodynamics. Done. So revision should look like that. And don't do any other question from any other book. Please don't do. Done. Just stick yourself to these things. Over. I wish again we will be meeting on Thursday. कल तो तुम लोगों का test होगा again on Wednesday, the last one. I hope everyone will be attempting test with sincerity. You will be doing it, and on Thursday we will be again discussing questions. So I believe that after giving test, certainly for 2 or 3 hours you will be again sitting with both of the papers and trying to analyze which question you did right and which question you felt like you were doing right but somehow you went wrong. Try analyzing all those things. Okay, so let's meet on Thursday again. I wish you very best and Thursday को फिर से मिलते हैं. उसके बाद एग्जाम है. Done. चलो ठीक है. Everyone stay positive. Don't worry at all. Just do your work. Okay. Bye bye. Take care.